So your first activity for today is to just grab your calculator and maybe a neighbor or buddy, bless you, and you're just going to take some time right now to basically enter problems like 1 and 2 into your calculator, which you may not even have to do for like number 1, but you type number 2 into your calculator and just compare it to number 1. And then you do the same thing with 3 and 4. You're going to type 3 and 4 into your calculator and kind of make a comparison between those two responses. Most important question in the warm-up is the question that is presently numbered number 10. When you go ahead and do number 10, I would like 2 sentences. So I am going to come around and check this homework from last night. You're going to go ahead and answer those 10 questions, and then we'll talk about these answers in just a second. Ooh, I also wanted to number your warm-up correctly very quickly. I forgot I did that again. So it goes 1, 2, 3, 4, 5, which is fine. This would be 6, 7, and 8. And then this one talks about 6 and 7. And then this would be 9, 10, and 11. So I'm sorry about that. Chopped up those numbers there, so that's for your reference when we go to talk about this. Alrighty, so hopefully I'm going to read off some answers right now for the simple calculation ones, and then I need you to talk to me about the answers to questions like 5, and then 8, and then 11. So I'm going to have you guys talk to me about those 3. So number 1, answers 2. Number 2, hey, how about that? Answers 2. And then number 3, answers 3. Number 4 should also be 3. So for number 5, what do you notice about 1 and 2, and then 3 and 4? Nick. Excellent. Excellent. Now, sometimes being good at math is a lot about being good at pattern recognition. So I'm hoping that you kind of noticed a little bit of a pattern. We read question number 1 as the principal square root of 4. What that means is that there's a little 2 tucked in there as the index for that radical. Same thing with question number 3. We read that as the principal square root of 9, which means there's a little index of 2 tucked in there. We never really write it. What I'm hoping that you began to observe was the fact that this number here is actually maybe the same as this number here, and then this number here, the same as this number here. And perhaps maybe it took you until 6 and 7 to maybe pick up on it a little bit more. For instance, the cube root of 27. You know that number very, very well. That's 3. Turns out, so is 27 raised to the 1/3 power. So do you see what happened in 1, 2, 3, and 4? Holds a little bit of water when it comes time for 6 and 7. Do you see that this index here matches the denominator of your fraction? So it's my hope that for number 8, you just noticed that once again you got the same answer. And now maybe you even notice how they're related. That's going to be one of your sentences in question 11, FYI. Okay, number 9. I switched it up a little bit. We have this cube root of 64. That's 4. Squared is 16. Turns out number 10 is the same answer. I changed really one thing about it. Did you see? This would be your second sentence for number 11. The denominator of my fraction still corresponded to the index of my radical, so the root that I took. However, what you may have noticed is that now, we have an exponent. Well, this exponent just matched the number that was the numerator in my rational exponent. So hopefully you picked up on that a little bit too. So question 11, when you answer it successfully, you've actually kind of taught yourself to some extent the 2 properties that we're going to talk about today in class. So for a second, let's just focus on the denominators of the rational exponents. Can anybody tell me the role that they play in a radical? Or maybe your first sentence in question 11? Go ahead, Mackenzie. Yes, very good. Did you hear that? Yeah? So the denominator, if you need it repeated, the denominator of your fractional exponent will always correspond to the index or root of your radical expression. Did you use index or radical? Or root? You used index, very good. It's a big kid word. Vocabulary in chapter 6. Nicely done. Okay, second sentence doesn't talk about the denominator of your fractional exponent. Go ahead, Joey. It does, and what about it? Yeah. Does that exponent have to be outside of the radical? No, very good. So that's good to jog your memory because that third property comes into play today. So we are back in 6.1. I don't know if you noticed that or not. Like we do bits and pieces of this chapter and then we cycle back and do some other bits and pieces. So we're back at the very beginning of the chapter. Again, if you were looking in your book. At the beginning of the chapter, they're trying to drive home 3 properties. Product property, quotient property, which you used and abused on your quiz yesterday wonderfully, by the way. I graded those. They look great. So power property, product property, quotient property, and then I just gave the third one away. The power property. And it went like this. You could actually write the cube root of 64 quantity squared as, and you should maybe jot this down too, the cube root of 64 squared. So that exponent could be either inside or outside of your radicand. Do you remember that one? A little bit? We're going to use it a good amount today, actually. Now you're probably saying, well, why don't we write it that way, Mrs. Lucas? Like, why do we have parentheses there? Well, remember, your Sam's calculator. Like on your homework tonight, I don't want you to use your calculator. So seriously, sitting there, you want to do that without a calculator? I sure don't. Square 64 and then try to cube root it? No, thank you. So this is kind of why we, have this property. There's easier ways to do the problem if you just chunk it out into pieces. So that's kind of the why behind that. Everybody have their 2 sentences for question 11. You sure do? Anybody need any repeats? I can put it on a notebook quiz. Right, got there 2? Go ahead. Yes. I'm going to check it for accuracy. Like, do you want to run it past me? Are you worried about it? No, you're good? Okay. Okay. Okay, so let's make these rules official, shall we? The first rule that we have is just when, at the beginning of the warm-up today, was just when you had 1 in the numerator. So basically that property says this. If you have a base, we'll call it A, and you raise it to the 1 over n power, that's actually the same as taking the nth root of A. So for instance, you have 16 to the 1/2 power. That denominator is always going to correspond to the index for your radical expression. Under your radicand, they're going to share that same base. So this is the same as taking the square root of 16. Square root of 16 is 4. Before I get too far into this, I wanted to just take a little bit of a moment to talk about the expectation for your work in class today and then the expectation for your homework tonight. Notice I show work whenever I do these problems. Even though I know mental math, I can figure out the square root of 16 is 4. What I need you to be able to do today is be automatic with the fractional exponent and the way you write it as a radical. So what I need to see in your homework tonight is grab yourself a piece of notebook paper, a piece of scratch paper, because you're going to end up cutting apart the puzzle that you picked up when you walked in. Your work for tonight should be just on a separate piece of paper. I need a minimum of 1 step and an answer. All I want you to do is the 1 step just needs to show me that you could take something that has a fractional exponent and write it as a radical. I will talk more about your homework puzzle at the end of class today. But as far as scratch work is concerned, this is the kind of scratch work I want to see. So show me you writing it as a radical, and then show me the simplified radical. So for instance, on part B, we have 32 raised to the 1/3 power. So that's the same as taking the cube root of 32. That is not done yet. Cube root of 32, I'm going to break that apart into its perfect cube factor and then the other number. What is the perfect cube that goes into 32? Doug? 8. Cube root each piece. Cube root of 8 is 2. Bring down your cube root of 4, and then that is done. So step 1 is I turn it into a radical. Step 2 is I simplify it. Part C is a little trickier because you have a negative exponent there. That's 108 raised to the negative 1/3 power. You can't have negative exponents be in an answer. So does anybody have any ideas as to maybe what we should do first? I'm not going to write it as a radical right away. How do you get rid of negative exponents? Go, Mackenzie. Very good. Upstairs, downstairs. Yep. So that's going to be 1 over 108 to the 1/3 power, which is going to be the same as 1 over the cube root of 108. And cube root of 108 actually does simplify. Oh, I heard it. Go ahead, Eric. Yeah. 108 breaks down to 27 and 4 as factors. Cube root each piece via the product property. So this is going to be 1 over, and then our cube root of 27 is going to be 3. Cube root of 4 doesn't simplify. I know what you're thinking. I can read your mind. You're like, there's a radical on the bottom of that fraction. Don't we have to rationalize? Because you just took the quiz on that yesterday. I will be honest with you. In this course, for the scope and sequence of the curriculum in Honors Algebra 2, you don't have to sweat rationalizing when it's a weird index. What I mean by weird is anything besides this 2 or a square root. So you will never have to rationalize in this class a cube root on the bottom of a fraction, a 4th root, a 5th root, a 6th root. The only thing you know how to rationalize right now is a square root. Some of you could probably figure out how to rationalize with a cube root or something like that in the bottom, but they'll make that official for you next year. If you're super interested in it and you think you got to figure it out and you want to run it past me, you know, swing by during homeroom, your study hall, lunch, after school. We can have a chat about that. But for what I'm going to test you on, you don't have to rationalize a denominator if it has a cube root or 4th root. Anything above 2 is the index. Is everybody okay with this answer? All right. Next up, 13 times x to the 1/3 power. Probably one of the bigger mistakes in really all of algebra. Remember, 13 has an exponent. It does. 13 is actually raised to the 1st power. So what goes under the radical? Just the x. So this is the same thing as 13 times the cube root of x. I would wager those of you that worked ahead, maybe a couple of you actually accidentally have the cube root of 13x. Be careful, because 13 has an exponent. Really common error. Hopefully you won't do that again. Right? Maybe. Okay. Questions on when we have 1 in the numerator, because now we have to go on to like other numbers in the numerator. Okay, I have a little mnemonic device to help you remember this rule. I actually call this little gem the ER rule. And no, it will not put you in the ER. It's just a nice way to help you remember what number goes where. So we're talking about any base A. And what I say is instead of doing your rational exponent with n's or something like that, just write it as ER or E over R. So that you know the top number, E, that stands for exponent. And the bottom number, R, stands for root. So if you do exponent over root or E over R, it helps you remember what number goes where, which is what I need you to master out of the 40 minutes that you're with me today. So with that being said, we could rewrite this now in not one but 2 ways. This could be the rth root feel like a seal when I say that, rth root of a raised to the power of e, or based on our power property for radicals, this is the same thing as the rth root of a raised to the power of e. Do you remember that from your warm-up? You could take that exponent that's in the radicand and move it in and out of that set of parentheses there. But the two steps are still exactly the same. You write it as a radical, you simplify the resulting radical. So for part A, step 1, I'm going to take the square root of 4 and then cube it. You could also move this 3 underneath. It's kind of was the phrase 6 one way, half a dozen the other. You get the same answer. So the square root of 4, that's 2. 2 to the third is 8. Part B, very similar. Just watch your signs. Grab a different color. So we have right now the cube root of -8. I'm going to raise that to the 4th power. So E, my exponent is 4. R, my root was 3. My ER rule. Cube root -8. That's -2. But then we end up taking -2 and raising that to the 4th power. -2 to the 4th power is positive 16. That's your answer there. Other questions about the first two? You guys seem to be doing great. Okay. 27 over 8 raised to the 2/3 power. Again, E over R, which means my root in this case is 3. And I would not square 27 or 8. Well, especially 27, maybe without a calculator. So I'm going to bounce this to the exponent outside of the parentheses. Quotient property for radicals says I could take the cube root of 27 over the cube root of 8. So that'll be 3 over 2. And then I can square it. Square the top and square the bottom. The answer to this one, 9/4. Now we have to do it with letters. But I shouldn't do it with letters if you don't understand it with numbers. We're all good with numbers? Letters. Same thing, E over R. So I'm going to take the cube root of x to the 4th. And then do you see how that shortcut of division actually works? Because, hey folks, fractions are just division. Remember how I was teaching you take 3 and ask yourself how many times it goes into 4 to simplify this? Well, now you can see why. It is now algebraically legit. You're dividing 3 into 4 when you do your fraction work. So I always think that's interesting. Kind of brings it all together. So we ask ourselves, how many times does 3 go into 4? 1 time. And how many is left over? 1 has to be left over underneath. Part E. Cube root of 2x to the 5th is how I would set that up. And then we just did a whole big worksheet on what to do with this 5. You distribute it in. So we have 2 to the 5th times x to the 5th, which cooks down to be 32x to the 5th. And then you simplify. So I have to simplify the cube root of 32, and then the cube root of x to the 5th is how this guy breaks down. Cube root of 32, 8, very good. So this is going to be 2 cube roots of 4. And then 3 goes into 5 1 time with 2 left over. We don't really ever leave our answer looking like that. We rearrange that multiplication. So we have 2x outside the radical, and then you'd have 4x squared left underneath. That's probably my toughest problem of the day. And I'm going to save part F and your independent practice as warm up for tomorrow. Tonight, you don't have anything with letters in it. Tomorrow night, different story. Lots of letters. Okay, I have to talk about your homework real quick. We got to number it before you leave me today. Let me show you how that's going to look. Remember, there is work to be shown for your homework tonight. Whoa.